Okay, hello everyone, and welcome to the 6th Ask Me Anything webinar with today's topic being sensitive data. So this is the 6th one, meaning there were 5 before this, and those webinars covered data storage, software, compute services, aggregators, and HPC, all in the EOSC context, of course. If you feel like you would like to know a bit more about these topics, I would recommend you to go to the EOSC Future website and take a look at past events. I will put the link in the chat in a minute. Okay, then next for this webinar, we are using Slido to ask questions and your feedback. So you can join us via your mobile phone using the QR code, or you can go to Slido, the website, enter this event code and the pass. I will also put this info in the chat in a minute. Okay, and that was it for me. Now we're going to go to our first speaker, being John Favaro, who is the communications leader for DICE. Okay, John, the floor is yours.
So I hope you can see my screen now.
Yeah, it's looking good.
Fine, great. So I am John Favaro from Trust IT, and I am the communications director of the DICE project. And today we're going to talk about the challenge of sensitive data in EOSC. Now, the topic of sensitive data has been growing steadily in importance in EOSC. We're starting to see services offered in the EOSC marketplace. Here's an example. And in fact, we'll talk about this one today. So I'd like to introduce our session by, let's say, sensitizing all of us to some of the issues around sensitive data in EOSC that many of us might not have thought much about yet, so that we can better appreciate what our researchers will be telling us. Now, the most common and obvious context in which we hear about sensitive data in EOSC today is health-related data. Certainly, the COVID-19 pandemic provided an enormous push. For example, work on genomic sequencing of the virus. There are also some high-profile EOSC initiatives going on right now, like the Virtual Brain Cloud and Health Data Cloud, which you see here with the links. Developing a GDPR-compliant sensitive health data service. And by the way, as important as GDPR compliance is, it's actually more complicated than that. Although the EU has certainly been a leader in harmonizing privacy law among the member states, it is a fact that national and state privacy laws around the world, and even in Europe, can be different. And this creates a challenge for EOSC researchers to always understand when they can share sensitive data and who they can share it with, especially across borders. And it even depends on the kind of data. For example, medical data has its own special rules for sharing that people are developing right now. And that brings me to another important point. Medical and health-related data are so high profile right now that some of us might get the impression that it's the only kind of sensitive data we might ever see in EOSC. But that doesn't do full justice to the scope of its relevance in EOSC. So let me give you a couple of examples. Smart cities are a high priority for the European Commission. And smart city applications are also highlighted as very representative use cases for EOSC Future's Data in Action initiative. But it is also being recognized that the data collected by smart cities can contain a lot of confidential information about citizens that could threaten their right to privacy. And we're not just talking about data like their names and ages, but also locational data, where citizens go in their cities, and the right to keep that private. Here's another example of EOSC Future's Data in Action that also concerns a high priority of the Commission, the environment. Now, since the environment is everybody's concern, it may come as a surprise that environmental applications could contain sensitive data, but in fact they could. Here's a quick example that we can all understand. If the data on nesting locations of rare birds became public, they could become even more endangered. The point we all need to see here is that sensitive data can appear in the most unexpected contexts in EOSC. And so we can't just make easy assumptions about our data. We have to think hard about whether and how it could be sensitive. So all of this is leading up to an important observation. We need to recognize the problem of sensitive data in EOSC, not merely as a problem of, say, data privacy, but rather as a full cybersecurity risk management problem. And this implies a systematic set of activities that extend across the entire lifetime of our data, including continuous monitoring for new vulnerabilities that might appear along the way. Having a systematic process helps us to think more clearly about what we actually need to protect and what we need to protect it against. For example, let's go back to the question of whether sensitive data is only about privacy. The first step in a systematic asset identification process uses a so-called CIA triad. Now, I can see why you might be thinking that CIA here stands for Central Intelligence Agency, but no, it doesn't. The data confidentiality is justifiably the top priority in EOSC applications. But what about availability? Now, that's about things like denial of service or ransomware attacks. Hospitals and medical institutions are being targeted by ransomware attacks. So what about somebody blocking access to your health research data? And what about integrity? Is there a threat of your data being corrupted or sabotaged by somebody? Now, maybe your analysis will decide that none of this is a serious risk for you. But the point is that being systematic forces us to ask these questions about every aspect of our data. So similarly, systematic threat analysis helps us to think more deeply about who might be behind these threats to our data. It's not hard to think of external threats. I mean, we all like to worry about credit card companies getting our health data, for example. But what about insider threats? Now, in EOSC, that might seem a little paranoid, but not all threats are malicious. They could be based on simple human error by our own personnel. So identifying these kinds of threats could lead to supplying good training programs and policies to our personnel as part of the overall sensitive data program. So this kind of systematic threat analysis and risk assessment is important to ensure that we really have thought through everything about our sensitive data from beginning to end. So now let's look at the problem of working with sensitive data in our context. After all, EOSC is the European open science cloud. Now, in open science, we talk about making our data open and fair, not hiding it. So how can we reconcile this contradiction while working with sensitive data? One compromise can be to make just the metadata open so that researchers can still search for data sets and then only access the sensitive data with appropriate permissions. By the way, even this requires answering some questions. For example, in some commercial and military contexts, people may not even want you to know they're working on something, that the data even exists. Now, that's rarely true in open science, but there are other compromises available too. For example, you can make the data and even the metadata freely available, but in anonymized form. That is free to use, but you can't trace it back to individuals or groups. It's a very powerful tool, and we'll hear more about that today. Here's something else that concerns us. EOSC is the European Open Science Cloud. So it's not just open science, it's cloud-based open science we're doing. Researchers are used to the convenience and, frankly, the necessity of working with cloud-based research workflows for their massive computing and data needs. They're used to working with virtual machines, which can often be conveniently self-provisioned. They will need the same kinds of cloud-based workflows to be available to them, even when working with sensitive data. So it's a big challenge to ensure that these workflows, which include lots of communication and lots of cloud infrastructure, are secured from end to end and still sufficiently convenient for the researchers to work in the way they're used to working. And here's one last challenge that is very specific to us in EOSC. As we all know, one of the fundamental principles of EOSC is the ability to compose and integrate services. EOSC is all about that. It's all about choosing from a variety of data providers, computing providers, analytic services, and composing them into the service we want. Unfortunately, a fundamental principle in cybersecurity. Every new interface introduces new threats, new so-called attack surfaces. And so when we're composing our EOSC services, we'll always have to be thinking about that, especially when it involves sensitive data. So now the EOSC researchers we're going to hear from today are addressing every one of the challenges I have mentioned in this presentation. So this is a chance for all of us to get a better idea of how sensitive data is being approached in EOSC and what lies ahead of us. And one of the things that lies ahead of us is a datathon on sensitive data that is currently being organized for the end of May. So if you think you'll be interested in participating, then save the date and stay tuned for more information on the DICE website as it becomes available. So thank you. And remember to put your questions on Slido, and I'll pass the floor now to our EOSC researchers to tell us about their work. I believe that our next presenter will be Abdul Rahman.
Yep. You see my screen?
Yes.
Yes. Can you put it in
Presentation mode? Yes.
Sure. Thank you. My name is Abdurrahman Azab. I work at the University of Oslo, and I work as a senior advisor in the Nordic Infrastructure Collaboration, and I'm leading the sensitive data task in the DICE project. So today I will give a brief introduction about our work in DICE for enabling service integration and sensitive data workflows. In DICE, we have our partners are service providers who develop services for providing access, open access and fair access with this ambition to sensitive data. One of those is CEST, Services for Sensitive Data at the University of Oslo, that is in production since 2014. This is Norway's largest platform as a service infrastructure for sensitive data. It has more 6,400 users and more than 1,600 active projects. We have 4 petabytes of storage, and it's provided as a national service via Sigma 2, which is the national infrastructure provider for research in Norway, financing high-performance computing and storage. In general, TSD isolation and security, all projects are isolated on the network level. It's a bit technical, but we isolate via virtual LAN. So each project in TSD has its own virtual LAN. So it's a hardware isolation, not software. We were using subnets before, and now it is even more with virtual LANs. Users network within the secure environment, work with their secure environment on their projects. there is a shared HPC cluster, but also the jobs run by each project isolated from the other jobs. So one user cannot see the jobs of other users running on the cluster. And all logins are enforced with two-factor authentication. Now it comes secure B2Share. Maybe some of you are familiar already with B2Share, which is mainly for storing and sharing research data. The secure B2Share is a special version of B2Share. It is based on B2Share, so that we get the user-friendly interface of B2Share as a metadata browser. But file upload functionality is removed. We don't upload sensitive data to the public website of B2Share, but records are pointing towards an access request interface. So you got the metadata about the sensitive data sets on the B2Share website, but if you want to get access to the actual data sets, instead of having the data set itself stored on the public website, you are directed to a web form where you submit an access request to the sensitive data. And this is how it looks like. So this is the main challenge, providing the sensitive data resources without violating privacy and maintaining fair principles. And the metadata stored in B2Share. So this is how it works. A user may access this through B2Find to our secure B2Share, or access it through secure B2Share itself. Or if we start from the actual workflow, the data owner stores the data here in TSD in the secure storage and can do some analysis on the high performance computing facility, and also can do additional analysis or look at the data through the VMs. We provide both Windows and Linux VMs. Now, if this user or this data owner want to make the data or the metadata about this sensitive data public, so that other researchers of the same interest can collaborate with this owner. This owner can register a record about this metadata on secure B2Share. And this is the main website, and this is the metadata database. And the user will link this record to the actual dataset stores here. Then when a researcher or a user finds this record interesting, I like this record, I want to get access to this dataset, then sends a request for access, which will be received by the data owner, and the data owner can accept or deny this request. Of course, the user will not be able to download this from the B2Share website, but this will be facilitated by the actual sensitive data processor, which in this case will be TSD. So TSD has its own way of exporting data, and this can be different from one infrastructure provider to another. So the mechanism that TSD provides for exporting data for requesters who get the request granted might be different. For example, in CEST sensitive data service might be different in other countries. So this is left up to the infrastructure provider. We cannot enforce this because there are different legislation, and of course the GDPR is for everyone, but the local legislation can be even more strict. So secure B2Share for TSD, datasets are registered by data owner via internal website inside TSD, and then the metadata is published on the website, and the access request is submitted via NetSchema. This is web form in Norwegian, and the request is granted by internal system notifying data owners. Once the request is approved, then the TSD publication system, which is for exporting data in a secure way, make sure that it is that person who's going to look at the data or download the data takes care of the exporting. Another service is the sensitive data service in Chinega, and it's a cloud-based, so it has a cloud HPC solution, and it is lose extreme power computing from the traditional HPC system, and it provides more control over data and access. And this is the website. There is a service deployment, resource abstraction, physical resources, service management, security and privacy. For security and privacy factors, for authentication, authorization, use of two-factor authentication, and it's an OpenStack CLI dashboard for the identity and access management, dedicated and separated storage, encryption and access control for the confidentiality of the stored data. And there is monitoring and incident response using cloud monitoring and network monitoring. And it is based on ISO 27001. If you don't know what is ISO 27000, ISO 27000 and its series, including one, this is mainly for network security. Sensitive data use cases, there are mainly two use cases. One is infrastructure as a service, and another is platform as a service. Infrastructure as a service, the users build their own platform using services available. You get the virtual machine, you install your software, and the admin users prepare virtual machine resources. Platform as a service, you get to use the actual platforms on the cloud system. So this is mainly for experienced IT users who want to use their own stuff, and this is mainly for more researcher type of users who have some IT competence, but they want to use the existing software and platforms. And there is the network of different Italian hospitals for Italian genomes in IG, with the aim to have centralized repository for human genomic variant data produced by various centers in Italy. This has to be based on a specific agreement between Chinega and each single center, and Chinega has been appointed as a data processor. So, and this is the same for TSD, and this is the same for CSC, sensitive data services. Most of the sensitive data infrastructure providers, this is their category. They are a data processor. It means the data owners put their data, they use the services to analyze the data and give the results. And once this is done, then the data is deleted from the data processor. The data processor does not maintain the right of having long-term preservation of the data. This is the data owner can store it in a specific data archive, but the data processor is responsible for the data while the data is being processed, and there has to be a data processor agreement signed. So this is how it looks from the technical point of view. The raw data, which is in red here, because this is pure sensitive data, it is ingested through the front end, and then it goes to the encrypted file system. And there can be some computation, of course, for the analysis, and the output is there, stored also in the encrypted file system. And when it comes to the exporting will be for aggregated data that can be exported through the backend. One example of that, if someone is doing variant calling for cancer patients, so you do the sequence alignment for the normal and for the tumor cells, and then you go through the different steps, and at the end you get a VCF file. This VCF file might not be sensitive, but the actual FASTAC and FASTQ file, this is the actual raw data that is sensitive data. So once you get the VCF file, if you want to do some graphs that are aggregated data, so not all the data that comes out of processing sensitive data are sensitive. So the raw data is sensitive, but the aggregated data might not be sensitive, but it's still, some aggregated data might be sensitive. There is this project or orchestra. This is mainly for connecting European cohorts to increase common an effective response to the SARS-CoV-2 pandemic. And I would go directly to this, how it works. So this is a service at Shenega where you have the recap and Opal servers where the data in the same idea stored with encrypted locks volume, and the data is data transfer is enabled through the internal network. And this will be the user interface. There is a data portal that is connected securely to these servers to do both launch the analysis and retrieve the results. And these are COVID data. There is another solution that is called Lanikia for storing and encryption of sensitive data. And this is based on the Galaxy web portal. I will go directly here. So you have the Galaxy, this is the user interface, and a file system layer based on XT4. And the data is stored encrypted on that file system. And then there is the virtual hardware layer. So these are a collection of virtual machines, Galaxy portal on a virtual machine, and then a collection of compute nodes to do the analysis on that data, and the data is stored on an encrypted volume. It is flexible so that you can have a backend, for example, a Slurm cluster, and each compute node is a virtual machine. So you can have this installed on the public cloud. Yeah, people get a bit afraid when I say sensitive data storage in public cloud, but it depends on what type of security you want to put. For some legislation, having good encryption is enough to put the data on the public cloud as long as it is encrypted. But for some other service providers, for example, in Norway, we don't trust that encryption is enough. So even if you want to analyze encrypted data, you have to do this inside the firewall. So when we deploy Lanikia in TSD Norway, for example, this has to be within the firewall of TSD. But in other countries, the encryption is trusted as long as the encryption mechanism is there. So this is a flexible solution for analyzing sensitive data and encrypted on the cloud. Yeah, so this was a brief description of our work in the sensitive data task, and this is our main contact, the mailing list. So if you send an email here with questions at any time, it will reach to all of us. Thank you.
Okay, then the next speaker is Manolis.
Thanks a lot. I'm Manolis Terovitis. I'm a researcher in Research Center Athena, and I will give a presentation focused on data anonymization and the tool that we have developed for data anonymization, which is called Amnesia. Let me start. Okay. Amnesia is an open source tool that provides data anonymization. It's freely available. Okay, you have already seen this, and you can send questions there. I'm going to describe first and explain the difference between the terms of anonymization and pseudonymization, which are introduced by the GDPR, and they have been mentioned before. Now, the idea, the key difference between these two techniques is that anonymization performs an irreversible transformation on sensitive data. Now, in all this presentation, I'm talking about personal data interchangeably with sensitive data, but sensitive data can be something broader than personal data, as John said in his own presentation. And the techniques that we present here, they can be used for anonymization, but they can be used to protect any type of sensitive data. So when we anonymize the data, we transform them from personal data to statistical data in the legal, following the legal terms of GDPR. And the key property of the statistical data and of this process is that it cannot be reversed. Once the data are anonymized, there's no way to go back and find the original data. Pseudonymization is the removal of direct identifiers, often followed by the insertion of a pseudonym, which can be a number. It's a measure that protects data privacy. It reduces the risk of getting a person recognized. The most obvious thing is if you have a catalog, just to remove the names, leave the rest information, and put an arbitrary number. But these kind of methods are reversible. There's no guarantee that we cannot go back to the original data. So in the terms of GDPR, these techniques result to protected but still personal data. So a key difference from the legal perspective is that anonymous, I think I have it here, that anonymous or anonymized data fall outside the scope of GDPR. You are not constrained to use them as personal data, but you can use them freely. And on the other hand, pseudonymous data, they remain personal data, protected to a degree, but still personal data. So the best motivation to anonymize is that we take the data outside the scope of GDPR. The key idea of anonymization is that there is some kind of statistical guarantee, a formal guarantee that the data transformation cannot be reversed, so there's a limited risk of information leakage. And it is probably the most suitable way to give data to third parties that you do not fully trust, or you're not allowed to give personal data to. So there's a question when to anonymize and when deciding when to anonymize. Sorry, this is the wrong caption, but the idea, what I wanted to say here is what are the limitations in anonymization. The key limitation is that you lose some information accuracy. Anonymized data are not identical to personal data by definition. So there's this magical property of data becoming no longer personal, but this comes at the cost of reduced data quality. So you must be certain that this is tolerable in your application. A key challenge for data anonymization techniques is to reduce to minimize the information loss while providing the desired privacy guarantee. There are some great boundaries between pseudonymized and anonymized data. I'm not going to delve into this here, but even in cases where you have some statistical guarantee that the transformation is irreversible, it can be partially reversible. And this is reflected to the many different privacy guarantees that exist. Still, based on the actual practice now, even the weakest of the privacy guarantees are a lot stronger and a lot more, they provide a lot more powerful protection that compared to what actually happens now in data sharing. And the last thing is that there is still a big challenge in automating this process. There's not enough experience, not enough feedback of the community. So the first tools that have appeared, they required a lot of effort from the user side. So as a solution to this, we have developed Amnesia, which is an open source tool made in Java. And to promote it a bit, the things that it does well, it is It is user-friendly. It works locally, even so it can work on your PC with the data never leaving your, with the original data never leaving your PC, or it can work on your cloud environment without any need to consume an online service. And this is important both for security reasons. It reduces the risks to have a completely safe data exchange over the internet, and it also helps you to adhere to legal constraints. We have put a lot of effort in enabling users to customizing the solution and regulating the information loss. And where the only tool that we know of that we support privacy guarantee in data transformation suitable for sparse high dimensional data. I'm using now the term set value data, which is the term used in the databases community for data that have an arbitrary number of values in a specific field. And finally, it allows, the tool has a clear distinction between the interface and the data anonymization engine. So it is easy to incorporate the data anonymization engine to third-party tools and information systems. It offers REST API, so you can bypass the interface if you don't want to use it, and plug it in your own ecosystem and work automatically with the rest of your tools. Now, I told you some theory and some background on what anonymization is and why it is useful, but I think an example would put some highlight on what we actually do. This is an example that appeared in one of the first papers around year 2000 about the dangers of pseudonymization. The basic technique for protecting privacy, which in everyday practice we called anonymization, although it's not anonymization in the GDPR sense, is just to remove direct identifiers. So in the United States, for reasons of transparency, hospitals used to publish pseudonymized data about user patient treatments, which removed names, removed identifying numbers, and let the descriptive data that you can see on the left cycle here. Now, at the same time, in the US, they had public voter lists, which had the data that exist on the right cycle that you see here. So these two data sets had for every person 3 common attributes, which were the date of birth of a person, the sex, the gender, and the zip code. So by intersecting this data, you could really re-identify the persons between the medical data, since it proved that almost everyone was unique if you took their date of birth, their zip code, and their gender into account. So this pseudonymization, which was not careful and did not provide a guarantee, was easily broken, and very sensitive information could be revealed. So one of the first and the simplest guarantees that were provided for data anonymization was k-anonymity, where the idea is that you transform the data so that each entry is indistinguishable from other k-1 entries. So if we assume that we have this data set that's on the left side of the screen, where where even if you removed names, you had 3 very descriptive fields, which was the age of a person, the nationality, and the zip code. Now, this information could be easily be found from other sources about the person. So if you could come here, you could find unique combinations that would identify each person, and then they would reveal the diagnosis that was performed on them. For example, simply if you knew that John was 29 years old, there's only one entry, that's the second entry about a 20-year-old person, and it would be revealed that she or he have suffered from, sorry, it was John, so he would suffer from heart disease. Now, by removing the accuracy of the presented information, for example, transforming the exact age to age categories, then we can create groups of K, which K is equal to 4 here, of identical tuples with respect to these fields that we call quasi-identifiers, and they can be used to identify a person. And then a third person cannot identify less than K records as candidates for a person about whom she or he knows this descriptive information, the zip code, the age, and the nationality. So it provides a guarantee that it protects the personal information, even if a third party has knowledge about a person from another source. There are weaknesses here. For example, if you know that the person is at their 30s, then you can infer that they suffer from cancer. And this is an example of the gray boundaries between pseudonymization and anonymization. But still, this is a formal guarantee that would prohibit any third person of reverse engineering this table and acquiring this. Now, the most amnesia and other data anonymization libraries, they automate the algorithm, and the most important input that's needed from a user is to provide the semantic rules that allow the replacement of the exact values with more generic values. For example, I'm going to the previous slide. Here, the age of a person was transformed to an age category, and we had 3 age categories: less than 30, in their 30s, and more than 40. This age category, if it's decided randomly by the algorithm, then it can lead to data that are not really useful, or to categories that do not represent semantically important groups in practice. So in key information that has to be provided to the algorithm by the user is how to create these categories. And for example, for geographical data, depending on the analysis we're going to do, then we can have multiple levels of generalized information of values with reduced accuracy that can be still useful, but they still make sense. So you can get you can group the European countries to Southern Europe and Northern Europe, and then all European countries to Europe. And the anonymization algorithm would start by checking if preserving the original values, if it's enough to protect user privacy, and if it's not, it would use more generic value. And if again it is not enough, to go up in this up and up in this generalization hierarchy till a solution is found. And this kind of semantic rules have to be provided for the anonymization techniques that are based on generalization. Now, this was all my theoretic description of the tool and generalization. I think I can take 3 minutes and show you how perform a quick demo of the amnesia tool. There are more detailed tutorials in videos online if you're interested, or you can send me an email. Now I'm going to just run the simplest scenario without examining all choices. This is amnesia. It runs now locally in my computer, although it is set up as an online service. It's actually an online service that runs locally. So the first thing is to choose a data set. We support several repositories and types of data. Now I'm going to load from my local disk a simple file. Loading happens similarly to how data loaded, text data loaded to Excel. If you had any practice, it works with delimited text files. You just choose here the delimiter, and then Amnesia passes the different columns and guesses the type of the data. Now, this is just a guess, so you might have to correct it. In this example, all guesses are correct. Now, these data are synthetic, simplified data that represent medical files from UK hospitals. So the first step in the anonymization process is to remove the quasi-identifiers. Now, if I stop here, I have unchecked the NHS number and the name of a patient. Then I have a pseudonymous data set where direct identifiers have been removed, and the only quasi-identifiers that can lead to the identification of a person, and actually to linking the diagnosis codes to the to an existing identity. So data has been loaded, and now what I have to do is provide the information on how these can be generalized. Now, for the marital status, I have pre-created a hierarchy, which is in a way, it groups it was a free text answer by the patients. So they have all kinds of responses to their marital status, and they are grouped to semantically important groups. Now, for continuous domains like numbers, ages, dates, Amnesia can help you auto-generate the generalization hierarchy based on the data that you have already loaded. And I'm going to do this here and create a generalization hierarchy for the date of birth. I'm giving a name for the hierarchy. And then, because dates are one of the most complicated domains, because we don't use the decimal system, but we rather have weeks with 7 days, then we have 12 months, and then from years and on, we use the decimal system. So I will define ranges where groups will, where values will be grouped together in terms of days, so to 7 days for 1 week. And then I will define groupings for months, and I want the weeks to be grouped to trimesters, and then the trimesters to 2-year periods. And from then on, if it's needed, then everything to group to 3-year periods. And this creates a hierarchy that's like this, where the original values which are not depicted here are grouped to 7-day ranges, which are grouped to 3-month ranges, 2-year ranges, and from now on, every 3 nodes are grouped to 1 node till there's a node representing the whole reference period. And now the last step to produce the anonymization is instruct.
I'm so sorry, Manolis, but if it's okay with you, we can go to the Q&A because it's only 10 minutes left. Or
okay.
Can you explain it very quickly? I don't know.
Yes, I will just give the final results, so
okay, great.
Someone can see how it looks. And now this is the original data, and here is the anonymized data, and you have a guarantee that these data are for anonymous. So you just save it to your local disk or save it to your repository, and this has concluded the anonymization. Now, the only part I've skipped is how you can do some tuning and choose where you're going to lose more or less information. So That's all from me.
Thank you very much, Manolis. Thank you to all of our presenters, and also thank you to our over 80 participants who have joined us today. We are now going to move forward with the Q&A session. As has been highlighted before, we have 12 questions now and 8 minutes to answer them. So we're not going to be able to go through all of them. What I would recommend is that those who haven't had their questions answered or who have specific questions to certain participants to contact them directly. And if some of you want to have a look at the questions which are available on Slido and want to send answers to the participants, if you want to receive further answers, feel free to exchange contact details with each other. The most popular one concerned metadata and metadata sensitivity. Some parts of the metadata are more sensitive than others. How are you dealing with these scenarios of different clearance levels to the metadata? Question posed to our presenters. Do either you, Manolis, or Abdulrahman have any thoughts on the issue?
I can give some response, although Amnesia only handles a small part of the process implied by the question. Amnesia, first of all, anonymizes both metadata and data, so it's the same where it is metadata of data. So if some data are more sensitive than others, then the way you can regulate the risk is by changing the anonymization parameters. In the example where you got the K anonymity privacy guarantee, if you use a larger K, then you get a more strict guarantee, and if you use a small K, you get a less strict guarantee. So by regulating the value of K, you can regulate the level of protection you give to different sensitive data.
Right. Next, there's a lot of certifications on data management already. Is there a concern that too many non-harmonized security standards will create adoption issues? Do we have any feedback or thoughts on the matter?
Well, there of course is always some danger of conflicting standards or non-harmonized standards. But note that Europe is getting its act together on cybersecurity, and there's quite a few initiatives now going on, both at the European level and the national levels. I pointed out in my presentation the ENISA entity, and there are also new things coming out. So keep an eye out for those, and that is part of the attempt to bring harmonization into the cybersecurity area.
All right. Manolis, I will have to ask you to be very short on this, but comparing Amnesia with ARCS, which is another popular data anonymization tool, what would you highlight as the bigger or the interesting differences?
ARCS, Amnesia and ARCS, they cover all very close use cases. ARCS has more algorithms providing different guarantees, but Amnesia is focusing on dealing with more complex data and with simplifying the process. So we keep working now with K anonymity in its variants, and we're going to add differential privacy. But our main focus is to use more complex data. We treat high dimensional data, which ARCS does not. And we also put a lot of effort in simplifying the process for the user with respect to ARCS strategy, which is providing more features and options.
All right, thank you. Now with research ethics, how does anonymized data comply with research ethics and the need to be able to prove that results are built on real data, linking to the issue of anonymization versus pseudo-anonymization?
I think this has to be treated in the research ethics process. It is not treated by itself in Amnesia, because I think that if you do your research on the original data and then you publish the anonymous data, then you actually have trained your model or drawn your results from different types of data. So either you have an internal process or clarify that it cannot work. But the key idea would be to, for anonymization, would be to provide large groups of anonymized data where the original research happens on the anonymized data. So the public anonymized data and the data that you use to do your research would be the same, the anonymous data.
Question from Ludovica Passeri, which builds on what has already been mentioned. How do we solve the specificities of national data protection laws in research data sharing, since the GDPR on scientific research leaves leeway for member states?
Well, I'm not a legal person, so I'm not certain how all the peculiarities can be solved. Anonymous data comply with GDPR, so in all national laws, they are safe. But now there are technicalities, for example, if you need consent to anonymize the data or not, if it is further processing, or if it's your right to anonymize the data and get the statistical data. But these are peculiarities that unfortunately I cannot answer now.
Right. 2 more questions and then I'll have to call it. Yes, does B2Share or Seneca offer their sensitive data services to third-party repositories that may want to use all or some of their sensitive data services? Really, that would be more for Abdulrahman.
If Abdulrahman is not able to speak to that, I will get back to you on this.
All right. In the meantime, then our last question, perhaps, let's see, how to deal with data that are anonymized today, but may no longer be anonymized tomorrow due to advances in technology.
Well, the anonymization guarantees provide the anonymization process that are here provide theoretical guarantees. So advances in technology will not really break exactly the privacy guarantee that is offered. Now, additional sources might break the privacy guarantee, or the problem might appear in fields that we have not anonymized now. We do not consider them personal. For example, I've seen another question about the CT scans. Maybe now you cannot reverse engineer them, but in the future you might be. So it is always a risk that has to be calculated. But the privacy guarantees do not break with respect to their input, because they're theoretical and they do not depend on technology.
All right, thank you very much. I'm afraid that is going to have to be all for now. There are some questions that are left unanswered. Mario Reale, to your questions about Géant, I would encourage you to contact the speakers you're interested in directly. Same with some of the other questions that have been posed. We will now release you to the rest of your days. Thank you again very, very much for what has been an informative and productive discussion. Feel free to exchange information, to exchange contact details, and we will see you all soon next time.